To review, there are four basic sump packages: a super sump with an ultra sump, a triple safe system, and the smart sump for crawl spaces with or without an ultra sump. As far as basements go, there is a lot to lose if your basement floods, so it only makes sense that everyone should have a triple safe. The only reason someone would not buy a triple safe is that they do not want to spend the money. But if someone wants their basement dry, we ask them if they want their basement dry all the time. If the answer is yes, then we show them how the triple safe makes sense. Because if you only have a single pump, how will you know when the pump has failed? How will you know when the circuit breaker is tripped? Or if the pump is unplugged? Or what will happen if the pump can't keep up with the amount of water in a heavy rain? And what happens if the power goes out in a storm just when you need it most? As you can understand, Triple Safe is the sump system of choice for everyone, and the one you should be talking to your customers about. Be careful though. Don't ever tell someone that they will never get flooded if they have a Triple Safe, or no matter what they have. There's always the chance that everything could go wrong and they could still get water. But by having a Triple Safe, your chances of getting flooded are statistically insignificant, or very low, and much lower than not having one. Let's review the pumps themselves. The Zoller lineup you need to know is: an M53 pump is a 1/3 horsepower pump. An M98 pump is a 1/2 horsepower pump. We've talked about these two already. An M137 pump is a 1/2 horsepower high volume pump. And an M266 is a 1/2 horsepower high volume pump with a 2-inch discharge line used to pump solids. All of these pumps are cast iron, 110 volt pumps with a mechanical float switch. The float goes up and down on a small rod. We avoid any type of pump that has a tethered float switch or a ball on a wire design. This is because they have to swing like this and they can get hung up in the close confines of a sump hole. These are made for big tanks like septic tanks where they can have plenty of space to swing. We also avoid pumps that have pressure switches. And this is a switch like this that hangs off the side of the pump, and as the water gets deeper, it puts pressure on this little rubber diaphragm that's inside here and pushes it up, which clicks a little micro switch and it turns the pump on. Well, they're not as precise as to what point they'll go on and off, and over time those on and off points change as that rubber diaphragm gets stiffer over time. So they're just not as reliable, and we don't recommend these. Oftentimes a pressure switch will have its own cord and the pump will also have a cord, so you have two cords coming out of the sump liner, and that would be indicative of a pressure switch usually. The M137 is for very high flow situations, as we said, and is so big you can't fit it into a sump liner with another pump. If you want to back it up, you'll need another M137 in another liner and back up both pumps with a generator. The M266 pump has a 2-inch discharge line and needs a 2-inch check valve because it's designed for sewage water. We would use this pump, the Zoller M266 pump, if we had an unusual situation where we had water coming in from the outside, so such as a trench drain in front of a garage door or some exterior source from the surface of the exterior where the water could have debris in it, like pine needles, leaves, acorns, sticks, and so forth, because this pump, the M266, has a big 2-inch hole in the bottom to suck all that debris out. Now, of course, with a 2-inch hole in the bottom, we're going to need a 2-inch discharge line, which is what this pump takes. You have a 2-inch threaded adapter to 2-inch PVC pipe. You need 2-inch fittings and a 2-inch check valve for this M266 pump. Another thing about this pump, very important, is that it has this packing tape on the switch arm to prevent the switch arm from getting jostled around in shipping. If you don't take this off, the switch arm can't go up and down, and it's not going to work. So you have to cut this strapping tape off of the switch arm and the guard when you install this pump. You have to do it. Otherwise, it's important not to have debris in a sump hole, especially floating debris, which can clog the sump pump switches. Be sure to remove pieces of the sump liner which float and any other debris from a sump hole before you put the lid on. If you ever had an application where some water in the sump hole was salt water, keep in mind that salt water is very corrosive to cast iron and will eat the pump in no time. So Zoller makes a brass pump for this application. Brass is unaffected by salt water. No, of course, you don't stand a chance of pumping the ocean down, but in some cases you could have a seaside home that in a very high tide would have some salt water mixed with the groundwater coming in. So a brass pump is what you want to use. Now these are special order, but we can get them for you. There are some other pump types that it helps to know about so you can talk about them. First is a pedestal pump. These pumps stick up out of the sump hole since the motor is open and cannot touch water. They are usually of low quality and performance, and it's a challenge just getting them to stand upright. Any submersible pump with a screen around the inlet is not recommended because they can clog easily. A Zoller M53 and 98 can pump half-inch spherical solids or small stones or debris is not a problem if it were present. Finally, plastic pumps are not recommended. They are cheap, but when they need to run a lot, the plastic holds heat and can distort. When this happens, the bearings go and the pump fails. Cast iron, on the other hand, is a perfect conductor of heat, which is good since the pumps are cooled by the water around them. Water-powered backup pumps are powered by city water pressure. The problem is that you need good pressure to turn them on, and even then they will only pump a maximum of 500 gallons per hour, which is seldom enough. You also pump out 3 to 5 gallons of city water for every 1 gallon of groundwater that gets pumped out, and you need a licensed plumber to hook it up, which makes it costly. Most other battery-powered backup pumps available are pitifully small and don't last. They may use automotive batteries, which do not last very long at all. Or they may use batteries that require adding water every 6 months, something a homeowner definitely will not do. Often, the pumping capacities of AC and DC pumps are grossly overstated by the manufacturer to make their products look better than they are. Often they will state, pumps up to 3,000 gallons per hour, or some such number. But that's at zero head. You don't need to pump water at zero head, it's already there. Basement systems lineup of pumps are the best suited systems for basement applications. Now let's look at how to install a sump system. First, let me remind you of Janeski's first law of hydrodynamics. Water flows downhill. Therefore, in order to make your water guard or dry track system drain most effectively, it's best to find the low spot and locate the sump there. Another reason is that if there is a plumbing leak, the water will run to the low spot of the basement floor where the sump is located and drain down through the floor drain. It just makes sense. You can find the low spot best with a laser level. You can also measure from the bottom of the floor joist to get a rough idea. Wherever you get the greatest measurement between the bottom of the floor joist and the floor is the low spot. Remembering that water flows downhill, water then is the ultimate level. You can ask the homeowner where the water gets the deepest when their basement leaks, or where does the basement dry last after it leaks? The answer is the low spot. If the low spot is in a finished area where you can't locate the pump, then you can run a feed line from that spot to the sump location where you can put the sump in the unfinished area. This feed line could be across the basement floor or right along the front of the water guard along the wall. Be sure not to locate the sump within 4 feet of an electric box, since that is against code. The idea there was from when discharge lines were metal, that you could touch the electric box and the metal discharge line at the same time. Before you begin jackhammering the sump hole, be sure that there are no underfloor utility pipes such as oil lines, sewer lines, a heat pipe, or electric conduits. Look around for these things in the basement and try to determine where they go so you don't hit them. If you do hit a sewer line, by the way, don't just cover it up when you backfill with some poor patch job. The sewer line will leak into the trench over the years, and the smell from the sewage will cause the homeowner to open up the floor and investigate, and they will know it was you. Ask me how I know that. Jackhammer the sump hole for a triple safe or any sump pump system about 4 inches wider than the sump hole has to be. This will give you space to backfill properly. We normally use a 3-inch wide bit for jackhammering floors, but if it's very hard, you can use a narrow 1.5-inch bit. Dig the hole about 2 inches deeper than the sump liner has to be if you can, to allow for some stone under the liner. If you hit hard dirt, you may loosen it up with the jackhammer or use a spade bit, which is like a small shovel bit on the jackhammer, to loosen it up. As you dig, throw the clean chunks of concrete or rocks into buckets or in a pile to be used for backfilling the sump liner later. Put the dirt or sand or mud into other buckets to be taken away. Before you finish with your jackhammer, notch the footing to allow for the drain outlet from the water guard. Much of the water that comes out of the water guard will just drop out of the bottom of the trench into the stone around the sump liner and into the holes that are in the sump liner. If you notch or slope the footing near the sump, it will help water get out of the water guard faster. Remember, when you set up your systems, you want them to work even in the worst, very hardest of rains. Take all the soil away. It can be used for filling in holes around the foundation to keep water away if there's no broken concrete in it, of course. The broken chunks of concrete can be used to backfill the sump hole as long as you use the chunks only and not the fines and all the dirt. We call any pipe that takes water from a drain system to a sump a feed line because it's feeding the water from a drainage system to the sump. The sump liner comes with a knockout for a 4-inch feed line from the drain system. If you hit that knockout with a hammer, you'll have the right size hole and you won't have to get a drill out. If you want 2 feed line holes to drain from 2 directions, then just mark the hole and get a hole saw or a jigsaw out and stick the blade in one of the 3/8-inch holes that are already there and cut your circle and saw it out. Be sure not to cut too big where dirt and stones can wash into the sump. Set the sump liner so that the rim of the liner is about 1/4 of an inch below the floor. This ensures that water will flow into the sump lid from the surface if there were a plumbing leak. Position the feed line hole towards the wall where you need it. Now drop in clean chunks of broken concrete, rocks, or clean stone to hold the liner in place. If you haven't already removed the knockout, you can trim it out with a PVC saw. Install the drain outlet from the water guard and a piece of 4-inch PVC drain pipe from it into the sump liner. This piece should stick into the sump liner about 1 to 2 inches. While making sure the liner is level and at the right elevation, you backfill the liner. First, use clean chunks of concrete and rocks to set it in place. This way, it's less you have to haul off and haul in. Then finish it off with clean stone. Never backfill with dirt and never sweep the floor into or around the sump or in front of the water guard. You want open spaces for water to flow around the sump, not mud. It's not a bad idea to set the lids on temporarily so you don't spill stone into the sump liner. Next, install clean pump stands. You need 2 clean pump stands under the M98, and it'll make the job easier if you use wire ties to hold them together as a set. When you set them into the triple safe liner, there are positioning guides that go around the legs of the stands. Be sure to get the stand locked into these. In a super sump or smart sump, the clean pump stands just get positioned in the middle of the floor of the liner. Next, glue a 16-inch piece of 1.5-inch PVC pipe in the top of the PVC T on the ultra sump assembly. Did you know that PVC glue will melt the check valve shut if you drip any down onto the moving flap of the check valve? Or at least it'll glue it shut. It's important not to drip any glue down the pipe when gluing fittings above a check valve. By gluing this piece of pipe over the ultra sump first, we can hold the assembly on its side and not risk dropping any glue down the pipe onto the check valve. The pipe we use is a thin wall pipe called SDR21. It has the same outside diameter as the thicker Schedule 40 pipe and uses the same Schedule 40 fittings. But SDR21 pipe is lighter and easier to cut and work with. Now we screw in the check valve into the M53 pump. It's not important that the check valve be screwed in very tight because it's below the water level. If it is screwed in very tight with a wrench, then it may be hard to get off at annual maintenance visits. Hand tight on the check valve is good. Now flip the metal handle on the pump over away from the white ultrasump pump and set the ultrasump assembly into the check valve. The ultrasump pump should rest on the shoulder of the green Zoller pump to support it. Use a wire tie to go around the ultrasump T and the handle and pull it tight. This holds the ultrasump in position piggyback on top of the M53 pump and prevents the ultrasump from rotating. Now, tighten the two hose clamps on the check valve nice and tight, preferably with a nut driver. Next, screw the check valve into the M98 pump and insert a section of pipe. It's best to put the rubber fitting under the sump lid on the M98, in which case this pipe section will be 5 inches long. Then the rubber fitting goes on and then another section of pipe. Set the M98 pump into the sump liner. Set the triple safe bridge into the liner and position both discharge lines into the cradles in the bridge and fasten them with wire ties. Slide on both blue pipe grommets. Pull all slack from all 3 black pump cords out of the sump hole. The cords from the other side of the liner from the cord outlet should be pulled over the bridge and set into the cord slot in the bridge. Set the second half of the lid on. Now, a little trick here is that when the guys took the lid off and everything out of the liner to install it, they stuck the lid bolts into the floor drain temporarily to prevent losing them. The pipes can be cut to even length above the lids, and the no-hub rubber fittings can be installed to absorb vibration and quiet the sounds, and provide for a means of disconnect to the discharge lines to pull the pumps out. The lid can be bolted down. Again, a nut driver is best. Then a yellow cord grommet is installed. One of the 4 round knockouts is punched out for the installation of the water watch alarm, and then drop the water watch alarm in.